Hello. This video is about the code pattern build knowledge base with domain specific documents. In any business world, Word documents are a common occurrence. And as you know, Word documents can contain raw text, tables, and images. And all of them contain important facts about the data. So in the image below, there is a textual information about an oncologist, Suresh H. Advani, present in a Word document, and also there is a table that consists of the awards that he has been awarded by various organizations. So in this code pattern, we will showcase how to process the raw text and the tables uh, in the Word document and how you extract the entities and the relationship between them and build a knowledge graph out of it, which can help in the further analysis of your domain data and which can provide you interesting insights about your domain data. So in this code pattern, we address the problem of extracting knowledge out of text, raw text that is available in the documents, and also the information present in the tables in the Word documents. So the major two challenges in processing the unstructured information is the NLP tools, the natural language processing tools, cannot assess the text inside the Word documents, which is present in the form of tables. And henceforth, it becomes an utter necessity that we process the documents as well as its raw text and also the information present in the tables. There are uh, domain specific and business experts who understands the keywords and the entities that are present in those domain specific documents, but training those in an NLP tool to extract the domain specific keywords and entities is a big effort, and it's it's very time consuming process as well. And sometimes it also becomes impractical in many scenarios that we find the sufficient number of documents to train the NLP tool to process that text. And then also you're not sure that if you can able to process you'll be able to process the information present in the tables or not. So in this code pattern, we are providing the methodology to overcome these challenges. So, the very conventional way of moving about this problem is you from the unstructured doc files, you convert the data that is present in the raw text and tables into a somehow semi-structured format. So the Python package Mammoth is works best to convert the doc files into an HTML files. From then onwards, we have written a Python code to extract the information present in the tables as well. And then we send that raw text and the information present in the tables to Watson NLU to extract common entities. So now the Watson NLU is not trained on a specific domain. If you want to train as I explained earlier, it becomes very difficult to train a NLU with your domain specific documents because there are many challenges involved in that. So sometimes probably a blend of both the Watson NLU and the rule based approach can do the magic for you. And that's what we have showcased in our code pattern. After we get the results from Watson NLU, we augment our results using our two code patterns, two existing code patterns, namely extend Watson text classification, uh, which augments the entity extraction part of it, and then the Watson document correlation, which augment the relationship between those entities uh, that are being that are being extracted in those from those domain specific documents. The user, the domain specific expert or the subject matter expert, they just have to configure the files config underscore relationship.txt and config underscore correlation.txt in both to process the code patterns, extend Watson text classification and Watson document correlation as per their domain. This is the high level architect diagram of the code pattern. The document stored the unstructured text from the doc files and the free floating text and the text information present in the HTML table, both that needed to be analyzed and correlated, are extracted from the documents using the Python code using Python memos. And then the results the results from NLU are augmented with the Watson text classification code pattern and Watson document correlation pattern. And then we have written a code to filter the relevant results. So the results, the only those results are picked up which are relevant to a particular domain, and from then onwards we have built a knowledge graph. The knowledge graph will somehow look like this. After you run the notebook, you can access the notebook from uh, from the notebook section here, and you can also access the data from the data section of it. And you should run this notebook, and ultimately you should get a graph like what I have told you. I have taken two documents, one on the oncology and one specific to a Suresh H at 1A. Both of them, they have table and raw text, and we have applied NLU and then augmented the results using Watson text classification and Watson correlation, and then we get the results like this. We get a knowledge graph. We have written functions to disambiguate the entities and build the knowledge graph, and you should get the knowledge. You just have to run the notebook and you'll get the results. If you want to tweak your this code pattern as per your domain, you just have to uh, make some changes in the configuration files here, config underscore classification.txt and config underscore relations.txt. Thank you.